you can either remember your difference of two squares, which you would automatically write it like this, w minus 2, w plus 2, because those are perfect squares. Or if you just like to swing everything, you could do this. What multiplies to AC and adds to B? Well, what is A here? What is the A value? 1. And what is the C value? Okay, what is 1 times negative 4? Negative 4. What's the B value there? 0. What multiplies to negative 4 and adds to 0? Negative 2, positive 2. So either way you go, whether or not you remember difference of two squares or whether or not you do swing on everything, this needs to be rewritten in factored form. It's not factors right now, it's a subtraction problem. Factors are things being multiplied together, and that's what this is. The first factor is w minus 2, the second factor is w plus 2. And so that's why you can factor w squared minus 4, but you can't factor w plus 2, w minus 2. And then once you have everything factored, you build your common denominator. It's like a group denominator, okay? Everybody's represented. All these denominators represented in the big group denominator. And so your LCD is built one factor at a time. This first denominator, w plus 2, has to be in the group denominator. The second one needs to be in there, w minus 2. And when you get to this last one, you look at them individually, you say, okay, I need a w minus 2, got it, check. I need a w plus 2, got it. The only time you double stuff in your LCD is if it's doubled in the problem somewhere as well. But nothing here is doubled. There's single ones here, single, single, okay. And so then that's your LCD, that's your common denominator. One denominator to rule them all. And then for each individual fraction, you multiply by what it's missing in order to match the LCD. So for example, in this first denominator, what is it missing to match the group denominator? W minus 2. So we take that original fraction, because remember that's our goal, is to get everything with common denominators, because that's what you do when you add fractions. But whatever you do to the bottom, you also have to do to the top. So if I'm multiplying the bottom by w minus 2, I have to multiply the top by the same thing. And what's the second fraction missing in its denominator? W plus 2. So I need to multiply that by w plus 2 on the top and bottom. And what's the last denominator missing? Nothing, right? It's not missing anything. So it doesn't change at all. It just stays the same. Oh, come on. So it's not missing anything, so it stays like this. And then once you get all the denominators the same, what can you do with them? Drop them. This is very satisfying. Just get rid of them. Bye. And then you're just doing the math on whatever you have left on the top, right? So that's w minus 2 times 5. That's going to be a distributive. Plus 3 times w plus 2, also a distributive. And then 12. Okay, so take a minute now and finish from there. On your papers, I saw people distribute, and then get 5w minus 10 plus 3w. I don't really say w, by the way. Plus 6 equals 12. Adding your w's, 8w minus 10, oh wait, sorry, negative 10, positive 6 is negative 4 equals 12. Then you add 4 to both sides. 8w equals 16. Dividing by 8 gives you w equals 2. Raise your hand if you got w equals 2. Caitlin, what did you get? How did you get that when everyone else got W equals 2? Which one equaled 0? Perfect. Who, y'all did not check for your what's? What is that called? What kind of solution when it doesn't work? Extraneous, right? Don't forget to check for extraneous solutions. If your solutions make any of the denominators 0, it's not a solution, right? It's extraneous. Because we can't divide by 0. It is undefined. It does not work. So right here it fails. When you plug 2 in for that W, you get 2 minus 2 is 0. And by the way, once you find even 1, that 0, you don't even have to check the rest. Okay? So, but she said she did check it into this one. When you put 2 squared there, you get 4 minus 4 is 0. So it fails there as well. And so the actual, since that was our only solution and it didn't check out, we actually have no solution. Okay? So no solution. Or empty set with your squiggly wigglies. Questions? Okay. You go to the denominators and you're just plugging them in for the W's, right? Because we solved for W. We're saying, all right, let's go check if W equals 2. Yeah, okay. And if it makes any of them 0, it's bad. It's not a solution. Does anybody need this up anymore? All right. Oh, we haven't even started notes yet. So I had this funny thing. What are the first most obvious differences in this problem than the stuff from Friday? Or the warm-up we just did? There's whole numbers, right? These two things are not fractions. But I actually think they really are fractions. How are those actually fractions? Put it over 1, right? By the way, retro question. This is a throwback Monday question. That was stupid, sorry. What do you call it if it can be written as a fraction? What kind of things are those? What was our classification for those kind of numbers? If it can be a fraction. Rational, right? So the 1 over 1, that is a rational. Because it can be a fraction, it's over 1. So we are going to start this problem as we always start them. And look for things that can be factored. Can't factor 1, because it's just 1. Now, if you wanted, you could do 1 times 1. And then you could, each of those is 1 times 1, but you could play that game all day. So just, it's not factorable. It's prime. X minus 3, class, can I factor that? No. It's 2 things subtracted, not multiplied, and it's a linear. We don't have any factoring methods for that. We have factoring methods for quadratics, but not linear. So this is just going to be grouped together instead, okay? Same thing for this one. So again, those 2 checks are, it's got an addition or subtraction and linear at the same time. That means you can't factor it. If it was something squared, we would try to factor it, but it's no. So then we just go straight to building the common denominator. Now, this denominator right here, that 1, I'm going to put it in the LCD, okay? Because remember, the LCD represents each separate denominator. But really, at the end of the day, multiplying something by 1 isn't really changing anything. The reason why I'm including it here is just for consistency, okay? Just to follow the procedure. Yeah. And then the second denominator needs to be part of the common denominator, so I'm going to put x minus 3 there. And then I check the rest of the denominators. On the right side of the equation, I need a 1. Well, I already have it. And I need an x minus 3, and I already have it. So my LCD is good to go. The next step is to multiply each fraction by what it's missing. What's the first denominator missing? X minus 3. So multiply the top and bottom by that. I'm just going to, instead of rewriting the whole thing, I'm just going to do it right here. technically, what is the second fraction missing? 1. You don't really have to write the 1. I'm going to write it just to keep up appearances. And what's the third fraction missing with its denominator? X minus 3, okay, top and bottom. And the last one, missing 1. Okay. So now that the denominators are all the same, we're gonna drop them. And here's what we have left on top. X minus 3 times x plus 1 times 12 equals x minus 3 times 1 plus 4x times 1. Thank you. See you tomorrow. So then here's where the difference in today's problems come in. Because right here, when you distribute this x, when you multiply it by that first x, it's going to give you an x squared. And so boom, now you're dealing with a quadratic and you have to follow all those procedures, like getting everything to one side, setting it equal to 0, combining like terms. So take a minute and try and solve that out, please. All right. So combining like terms on the right gives you 5x minus 3. And then you have to move the stuff on the right over by doing the opposite on both sides. That gives you x squared minus 8x plus 15 equals 0. And y'all were mostly, when I was walking around, y'all got there. That was good. Now you factor from here. What multiplies to 15 and adds to negative 8? Negative 5, negative 3. Dividing by the a value doesn't change anything. So that's x minus 5, x minus 3. By the way, that is factored form, right? I verb factored that trinomial to this form. And noun, these are factors. X minus 5 is a factor, and x minus 3 is a factor because they're things that are being multiplied. Okay? But then now we actually have to solve it. So that factor gives me 5. That factor gives me 3. Which one of those is extraneous? The 3. Because if I were to, check it out, up at the original equation, it would make this denominator, both of the x minus 3's, it would make them 0. Okay? And so it can't be a solution then, because that's undefined. So what I would be looking for on a quiz or test or whatnot is some proof that you went through that mental effort to show it's extraneous. Like, the simplest thing I would be looking for is you just crossed it out. But on your homework, like when you go check my homework key, the homework says identify. So I actually went through the trouble of writing this out. X equals 3 is extraneous. So what I'm trying to say here is you could get lucky and just have done the math that got you x equals 5 and never come up with x equals 3. So while technically your answer would be correct, it would be a partial credit because part of the process is getting the x equals 3 and then checking that it's extraneous. So be careful for that. Questions about this one? All right, we got one more to do. And some of you have already tried factoring the 6n squared minus n minus 1. So even if you haven't tried factoring, I still want to talk to you all about it. This right here is a good example of why the swing method is called the swing method. Okay? It starts out the same as we've been doing. What multiplies to AC and adds to B. So I'm right here on the second problem. AC is negative 6 and B is negative 1. And for those of you who have already started, what two factors did you get? That multiplies negative 6 and adds negative 1. Negative 3 and 2. And then we divide by 6. So everything's going along nicely. Same-o, same-o. Negative 1 and negative 5 doesn't multiply to negative 6. Okay. And so what we've been doing from this step is writing our factors like this. X minus 1/2, x plus 1/3. Oh, it's supposed to be ends, I'm sorry. But you get the point. And then I left it in this form because we were solving all this time. And that's a perfect form for solving because you just do insider's lie. But when we need it in factored form is where we swing the denominator, the 2, we swing it back up here. And the 3 swings back up here. And I'm going to switch back to n now because I had to accidentally put x. So that would now give me 2n minus 1 and 3n plus 1, which is fabulous because it matches those other factors. If I were trying to work with these fractions, it'd be an awful ugly mess. And you could go about this problem, the beginning, 2 different ways. My way, where I factored and noticed that these 2 things happen to be the exact same as these 2 things. You also could just multiply these 2 things together, the 2n minus 1 and the 3n plus 1, and see if it gives you that. Either way, you could begin in either method. Well, I'm not distributing anything. Do you mean? Oh, you're good. Okay. Okay. And so then now that I have these factors, I'm just going to rewrite this denominator like this. And then build my LCD. Raise your hand if you know what the LCD is already. You're good. Okay. It is this, correct? Good. Okay. I'm going to show you like a super uber fast shortcut, cut out a whole bunch of writing way to do the problem, okay? We already know we're trying to drop the denominators, right? So I'm just going to drop them right now. And then we already know the tops are going to be multiplied by whatever's missing in the bottom. So I'm just going to write that thing just on the tops. So in the first fraction, what's missing in the bottom? Nothing. So I don't have to do anything to the top. In the second fraction, what's missing on the bottom? 3n plus 1. So I'm going to multiply the numerator by that. And then what's missing in the last fraction? 2n minus 1. So I'm just going to multiply the top by that. Okay? So I basically just thought through everything, and I just saved myself a whole bunch of writing. And then this is what's on the next step is this 3n times the red, 3n plus 1, that's going to be distributed. Same thing here with that 4n. Please understand, that thing you're distributing has an n attached to it. So it comes along as part of your multiplication. We don't usually have a variable there, so it's easy to forget about, but don't. So that first numerator was negative 18, right? It's a negative. I covered it up. Negative 18. And then when you distribute 3n, that's plus 9n squared plus 3n. And then on the right-hand side, 8n squared minus 4n. Okay. So take a minute and finish off that. Move your stuff over to the left. That gives you n squared plus 7n minus 18 equals nothing. N plus 9, n minus 2 equals nothing. That gives you n is negative 9, 2. Who checked for extraneous solutions? What'd you find out? None of them are, right? So it's negative 9 and 2.